we do not know yet whether we're going to have to solve this problem with SAFs alone, or whether a technology is going to come in like Tesla did with battery electric cars. And so our aim with these should be to maximize the chance as early as possible with understanding whether they can play a part in the solution. And there's a number of them, but the cost of actually trying these out to a level where we understand whether they can play a part is important.
Welcome to Sustainability in the Air, the world's first podcast dedicated to sustainable aviation. I'm your host, Shashank Nigam, the CEO of Simply Flying. Every Thursday, I have important conversations with top aviation executives, technology entrepreneurs, and policymakers helping aviation take climate action. Conversations that help separate the signal from the noise. Whether you are a frequent flyer or an airline executive, if you care about sustainability or simply love traveling, welcome aboard. My guest today is Dr. Rob Miller. Professor Miller is the head of the Aviation Impact Accelerator at Cambridge University in the UK. Most recently, his lab released a very poignant report which talked about accelerated action that airlines can take in the next 5 years to help spur an entire sustainable aviation industry led by technology. I asked him why the next 5 years are so important, and it's about momentum. Momentum is important for airlines to get started today. Prof. Miller drills down into each of the measures and metrics that are important for airlines and actions that they can take today to ensure that over time they meet and potentially exceed their net zero climate goals. I hope you enjoy this conversation with one of my favorite academics. Professor Miller, it is a pleasure to be finally speaking with you after all of these months and months of interactions we've had. We've exchanged notes, we've shared stages and in different places. So it's good to be finally speaking. And specifically, I'm very curious. Your team went ahead and came up with a 2030 Sustainable Aviation Goal Report and not 2050. Why is 2030 so critical?
Well, I agree. It's great that we finally get to do this, and it's a lot of fun. So many thanks for inviting me. It's very kind. It's really interesting. So the Aviation Impact Accelerator is a sort of team of experts across the world developing this model. And what's interesting is as we get more into this model, we find that the traditional wedge charts you see that lots of companies use, they're pretty standard, they're quite misleading because technology transitions, there's two rules. The first one is that in the end state, there's usually only one technology, maybe a marginal second technology. But if you look VHS, Betamax, the car versus the horse, canals versus railways. In the end state, there aren't two. And in addition, technology transitions aren't smooth. They happen very non-linearly. And so as our model has got more complex and we've built in different systems, a lot of the technical analysts working on it can see these bifurcations or tipping points. Effectively, there are actions which you can take in the next sort of 5 years, few years, which open up whole new futures. Or if you don't take the actions, you close down those futures. So we really felt that we wanted to communicate this idea that you need to act, and you need to act with certainty now. And the final thing to say is, as we were sort of exploring the system, you find these key leverage points. There are things, definite things, which if you do them, have a much bigger effect than other things. And so we held a workshop with MIT NASA, the Federal Aviation Authority, EU Clean Aviation, the Department of Business and the Department of Transport in the UK. And we held this workshop over at MIT. And in that workshop, we could feel these 4 areas where action was taken. And that's really where it comes from. And we wanted to explore those.
Very interesting. So let's start with this workshop at MIT. Tell me more about this workshop. Who was there? Why was this workshop convened? And what were the conclusions?
So the workshop was convened because the AAA launched its first public tool at the Farnborough before last. And after it, the chief scientist of the Federal Aviation Authority, Jim Harman, walked up to me and he said, look, we don't really have this sort of model. I've not got access to it. Could you come over and work with your partners at MIT? And could we run a workshop where we sort of explore the future? And what we found is it's incredibly powerful if you get the key policymakers together around this tool. They're working on touch screens. It's sort of like the Minority Report. You can sort of try things out. And so we decided we'd get this workshop together. Jim said, you really need to do it in the States. If we're going to get a good amount of people there. We had the chief scientist of the Department of Transport, Sarah Sharples, came. We had Holly Grieg, who's the deputy head of the Jet Zero Council, Jean-Francois Brockhart from Clean Aviation in Europe. And it was a really great group. And we feared before we went, actually, that the policies in the EU, Britain and America were not very converged and that it would be tough. But I think once you get these people playing with the real numbers and seeing how things interact, it's just really exciting. And so we these 4, the essence of the 4 came out of it. And then we spent quite a long time over the summer working on them. And we were asked by the King to do a preview to them at the opening of COP28 in Dubai. And then we've been working hard ever since to sort of really evidence them right down into the deep levels with our industry and academic partners. And the report really covers them.
Interesting. I see where you're coming from in terms of the regulators and the different agencies coming together from the UK and Europe. There was also MIT. So is this then a joint report between the Witter Lab and MIT? How do you collaborate between academic institutions for outputs like this?
Yeah. That's very important. So a lot of the work is done between us, but we had a core team who really went down in the model and evidenced the stuff for the final report. But the original ideas, the workshop, all those things are jointly developed.
Fantastic.
Between the two.
It's great to see collaboration because it's one of the key foundations, cornerstones of sustainable aviation. We have to work across oceans, silos, and different industry players.
By the way, it is a big challenge because I think one of the big challenges sustainable aviation faces in the future is if you get everyone together and you build a coalition, it's incredibly powerful, but you average towards what people are doing at the present moment. You also have to have an element where, you have to put a little high performance team together. Like a Formula One do. And you have to really go into all the evidence in real depth and evidence something. And that can be braver. That can push the boundaries more. So you can really think of the group, the Transatlantic Sustainability Group, as as 2 elements. You've got one element, which is really pulling together a consensus, building bridges between them. And then you can think of the way the model is working or the report is working as sort of pushing out there and trying to push ambition. And then we're going to come back to the group now, and we're going to have our next meeting where we sort of work forward from there. I think this dual element of building coalitions, people working together, and then deep specialist multidisciplinary teams punching out and looking at the evidence is a good combination.
It's fantastic to hear this and very encouraging, I have to say. I love the fact that you're taking an aviation 2030 approach to this because in the recent past, there have been airlines that said, oh, you know what, we're going to do away with our 2030 goals. We just look at 2050. But you're saying you have to focus on the 2030 if you want to attain your 2050 goals. Is that right?
Yeah, that's absolutely right. So predicting the future out to 2050 is a fool's game. I mean, so you're not, I always think aviation is in a pre-Tesla moment. So basically the car industry in the early 2000s was really focused on producing biofuels, and they wanted to deliver those biofuels in a sustainable way. Nobody could have predicted the Tesla moment would have come, but the Tesla moment has just bifurcated their whole system. And you can see this all over the aviation system. The key thing is to move the date forward at which we have an idea whether these technologies will become the Tesla moment. It might turn out none of these work, but if you notice in the report, and I'm sure we'll come to it, one of the chapters is about moonshots. And the reason for that is there are a series of technologies which have the potential for a Tesla moment and are not that expensive to evidence at a level that you could make a decision whether to go for it. And really what we need to do is work out what those are and focus on them over the next 5 years to determine whether, for instance, we should forget hydrogen or we should focus.
So let's hit each of these. Let's hit each of these pillars one by one. You start the report with Operation Blue Skies. What is that about, and why is this stage so important?
So, as I'm sure your listeners will know, that about 1 in 20 flights produces a persistent contrail, a cloud, and those clouds effectively trap in the heat. They do reflect heat as well, but on average they are damaging. Those 1 in 20 flights does about the same climate damage in that 6 to 12 hour period, we think, in terms of warming, as all 20 flights CO2 does over 100 years. So these are big effects. Now, the challenge here is that we know that the effect is large. We don't know how large. The uncertainty is large. But there's a method of avoiding them, which is to change altitude. The areas, the ice supersaturated regions in the sky are like pancakes. And therefore, if you're in one, you need to change altitude up or down so that you stop forming that contrail. Now, the challenge is there are multiple uncertainties within the system. And the uncertainties include air traffic control, flight planning, weather modeling, and the vast number of people who have to be organized to make sure this operates correctly. And the only way in these sort of problems you learn is to learn by doing. And a number of trials have already been operated, but they're not at the scale to see all the real world uncertainties. So we believe that airspace-wide living labs need to be put in place. And those living labs have to sort of have 4 elements with them. They have to, there has to be a distribution of them. There has to be a few of them, and that's because different airspaces have different characteristics. The North Atlantic is not the same as the busy European airspace. So you're going to need a number of them. Each one of them is going to have a scale. It's going to have to be of a scale to see the real problem, a large enough scale. They're going to have quality. You're going to have to be monitoring them in such a way that you can, like a medical trial, that they're doing the right thing. And finally, you're going to need review. You're going to have open data. You're going to have peer review. You're going to have to tell that they're correct. And we believe if those airspace-wide living labs could be started immediately and completed by 2030, we believe we'd be in a position by 2030 to start the process of a global rollout of a contrail avoidance.
This is very interesting, and I love how you deep dive into it and showcase, different regions. My understanding is that a large majority of contrails are over the North Atlantic, for example. But what you're saying is there's such a huge uncertainty in terms of the warming effects, the humidity of these, that few airlines are willing to act on it. The last airline who conducted trials could tell me, with certainty, this is the increase in fuel burn. But with huge uncertainty, we do not know whether we reduce warming contrails or not. How do you address airline concerns like that?
Well, so this is the reason proper trials need to be done, because each individual player through the system is desperate to do the right thing. The airlines are desperate to do the right thing. But if you just start it off and you allow individual players within the system to just go off and do these things, then each player, is disempowered within the system. You really need these. I mean, I think the UK is currently working on such a trial. I think the EU is talking about such a trial, and I think they need to be carefully worked out. To start with, you'd only manoeuvre a few planes, and you'd look at the consequence of those. You might film them with satellites, at the same time as monitoring their fuel carefully, modeling the weather before and afterwards to see whether you've got the effect you want. And then you start to scale them out to larger numbers where airspace issues become critical within the problem.
Question for you then. Who's going to pay for these trials? Because airlines are usually thin margin businesses. We are telling airlines, this may result in a fuel bill increase by changing altitude compared to your optimal altitude. And yes, you will contribute to overall research. Is this something that governments should be paying for? Is this something airlines should be chipping in for?
So it's in terms of the climate benefit, this is a very small extra cost, a few percentage. We show in the report a few percentage points on the price of the ticket. So it's not a big cost, but people won't do it unless they have to do it. So the question becomes, do you just require people to operate within that airspace to abide by the rules, or do you incentivize people in some way to make those maneuvers? But I think the cost is so small. I don't think it's clear yet, by the way, which of those two you should follow. But I think the cost is so small and the climate benefit is potentially so big that I don't think that's the big part of the problem. I think the big part of the problem is we don't know at the moment whether the current geostationary satellites have got the resolution to be able to determine this accurately, or whether low Earth orbit satellites will be required. We don't know how many of these contrails can be avoided by just changing the flight plans without satellites. So these basic questions of how you intervene, I think, are the initial.
Fair enough.
Problem.
Definitely, we need a professor or a bunch of professors working with the airlines here. Since we're talking about fuel costs, you talk about bold measures that can lead to significant fuel burn reduction. And as we know, fuel burn reduction leads to a reduction in CO2 emissions as well. What are some of the things airlines can do today or bold measures that they can take today to reduce their fuel burn?
Yeah, we've done a lot of analysis. Our second goal is called systems efficiency. And the reason for that is that there are a number of efficiency measures already which everyone is talking about. And things like air traffic control, bringing in accelerating technology deployment, decarbonising airports, all those things are very important and will probably lead to about a 20% fuel burn reduction by 2050. So that's a lot of consensus on that. What's very interesting is that there are a number of what we call bold measures that are currently not being talked about as much. But if you put them in place, you could halve fuel burn by 2050. Now, the fuel burn is predicted to more than double by 2050. So this can actually flatten off the growth if you put it in place. And the problem with these bold measures is that the aviation sector is incredibly efficient at the moment at minimizing fuel burn, but there are certain efficiency improvements which are systems wide. So they're very hard. Airlines can't get at them, and the manufacturers of the planes can't get at them, and the air traffic controllers can't. And we need some way of incentivizing this change. To give you an example, in cars, the CAF regulations in the US that were set up in the 90s demand that car manufacturers, each company reduces the amount of the fuel burn per passenger mile or car mile per year. And that has forced the manufacturers to drive the fuel burn down over time. And you could imagine similar things, green credits for the right aircraft bought, scrappage schemes. There could be all sorts of things that would bring these in. But do you want me to talk about the measures themselves?
I would love to see what airlines can do today to reduce some of this fuel burn, some of these bold measures.
Well, so some of them can be brought in immediately. Other ones, the majority of them, actually require new aircraft into the fleet. And so that is a challenge. So some of these come in relatively quickly. Other ones take much longer to get into the system and require a certain level of coordination. So the first one is accelerated fleet replacement. So we all know at the moment of the problems with Boeing and Airbus in delivering the aircraft they've promised to deliver. And this is not an easy thing to achieve in the short term. But the aircraft manufacturers, Boeing and Airbus, have already said they're going to double the number of planes produced by
2050. That's right.
2050.
That's right.
Yeah. If they were to triple it, not double it, then that would effectively halve aircraft life. So it would take aircraft life down from about 30 years to about 15 years. And that acts because there's so little carbon in the plane itself, the actual production and destruction of it, most of the carbon comes from the fuel. What you find is that it accelerates technology replaces fleet faster, and you can get about 11 to 14% reduction.
If Boeing and Airbus triple the production as opposed to doubling.
Rather than double, if they tripled it. Now,
this is so interesting because what does this do to asset values, right? As we know, airplane lives are about 30, 40 years, and leasing companies value them that way. Aircraft manufacturers value them that way. And I was recently reading a journal which showcased that delivery rates or renewal rates of fleets have reduced since the pandemic and not increased. That means airlines are keeping less efficient planes longer in their fleets and not for a fewer time because of cheap operating costs. And I would question then, isn't this a very interesting opportunity for a third player like Embraer to come in and say, oh, here are some E2s and I've got some slots available, come take these. And airlines like Porter, I believe, are doing it, or what Qantas is doing with the A220. I think there are some very interesting opportunities if we go off the traditional beaten path here, isn't it?
I completely agree with you. I think either the current manufacturers will increase their production. And to be honest, if they're given, the reason they don't is because of the risk of doing this and the assets. So if they're given certainty through forms of green credits or scrappage schemes, if they're given that certainty, and we believe that leading governments need to put the indicators out pretty quickly that they're going in this direction so that the people can start to make those planes or plan for the factories in the future. So I don't think that is a challenge. But I agree exactly with what you're saying, that a third manufacturer coming in would just solve that problem. And whether that manufacturer is from China or whether it's from Brazil, it doesn't really matter. But I'm pretty sure if you asked me to take a bet on whether the aircraft manufacturer would triple by 2050, I think I'd take that.
Fair enough. That's a very interesting recommendation. Do you have any others around the bold measures?
Well, so the second one is flying slower. So at the moment we push up to what near the speed of sound. And in doing that, our wings are swept. And that structurally is not the most efficient way to fly. So if you back off to about Mach 0.72, about a 15% slower speed, you can save about 5 to 7% efficiency. So that's not flying current planes slower. That's actually producing new planes that fly slower. And that's about 50 minutes extra on a transatlantic flight. Now, this is a disadvantage. This is what, it's a slower flight. So, it's it's not straightforward for people to accept. But the times that we spend in airports waiting for flights, I don't know whether we could offer something at a sort of whole travel time level, which would compensate for those 50 minutes.
This is so interesting. Again, rings a bell from the last Southwest Airlines earnings call, where the chief operating officer talked about taxi fast and fly slow. And that's how they're able to reduce their fuel burn and increase rotations because they're taxiing faster. So their ground time is lesser and they're increasing turnarounds.
Well, it's very interesting you said that, because actually I haven't really got into this, but it's in the report. That 5 to 7% is partially actually making sure existing aircrafts fly at the right speed, because aircrafts tend to fly faster than their ideal speed because of this non-linearity. The nearer you are to the speed of sound, the worse it is. So I think, I can't remember exactly, but I think about a third of the benefit I've talked about, the 5 to 7%, comes from actually it's just making sure we fly the existing planes
slower
at the right speed. Yeah. But the other is to do with bringing aircraft into the fleet that fly slower. And we were very pleased. I mean, the Times in the UK wrote a leader that said they thought it was a good idea and they'd get an extra gin and tonic on the plane. So I think you'll be surprised. The public are feeling guilty quite often about flying. And I think this is a sort of, people will accept a little bit extra if they can keep on traveling. And then the third that is worth about between 4 and 7% of fuel burn reduction is to do with matching aircraft to the right range. So the thing about an aircraft, as you'll know, is they're designed, they have enough metal in them to fly their maximum range. So if you're buying an Airbus A320 and it's designed for 6,000 kilometers and you're flying it every day at 800 kilometers, then effectively you're carrying too much metal around with you for that flight. Now, there's various elements to this matching range. One of them is we are just not using the planes we have at the right ranges. And so you could incentivize people to use the right planes at the right ranges. Another one is that if you look, and there's a brilliant piece of work done by Brian Yutko and John Hansman at MIT that we use. They run machine learning on the whole aviation system. And they found that if you put 2 new aircraft in, one about 8,000 kilometers and a new aircraft in at about 2,000 kilometers, they're points in the system where there aren't aircraft at the moment, and that would mean more aircraft being used in a more efficient way. There's not many flights around 8,000 kilometers, but it's a big benefit if you build a plane, whereas down at 2,000 kilometers, there's lots of planes, but the benefit's not as big. And you put those two together and they're about equal. And then the very final bit of it is that, and this is work done again by Brian Yutko and John Hansman, if you split flights over 10,000 kilometers into 2 legs, you can get quite a big benefit. But you've got to be realistic about this, because only certain airports exist and they only have certain capacity, and you have to fly different routes to get to the airports. But in this analysis, if you put that together with the 3 things I've talked about, matching range, we think about 4 to 7% fuel.
Wow, this really adds up to a lot. I have a lateral question for you here. What do you say to guys who want to fly faster, like folks at Boom who want to bring back supersonic? What's the answer to them then?
I think for me, travel is a sort of human good. Only 10% of the world has ever flown, and so we've got all these people, new rising middle class in Asia, Africa, South America, who want to take their first flight, and they have a right to take their first flight. And so I think if you look at the size of aviation's climate impact as you reach 2050, it becomes really significant. And so my own view is we should be really focusing on making sure the maximum number of people can travel the largest distance with the smallest climate impact. And I don't see how supersonic flight fits within those metrics.
I hear you.
Honestly.
I had a very fascinating chat earlier on the podcast with the CEO and founder of Boom, Blake Scholl, who of course believes in an alternate reality for humanity as well. I think he had 80 routes that he wants to fly supersonic on. That let's see if the project sees the light of day or not. You also had a significant section in the report around sustainable aviation fuels. What role do you feel SAF will play in helping aviation decarbonize?
Yeah, so the third goal, as you say, is about SAFs, and we called it truly sustainable and scalable SAFs. But that depends very much on the particular SAF route you follow.
You talk about truly sustainable and scalable fuel and its importance in achieving net zero aviation. How are we going to scale SAF?
So SAF is out the gate. We have mandates in the EU. We're about to have we have mandates in the EU. We're about to have mandates in the UK. So it's already happening, but we need to be able to scale it faster. And to scale it faster, the public and investors need to be confident that it's truly sustainable. And in our model, what we find is the real challenge is the vast or the incredibly large resource requirement, the biomass that's required and the electricity that's required. And if you don't, at the moment, we consider the aviation sector. But in these limited resource scenarios we run through the model, aviation ends up pulling resource off neighbouring sectors. And when you account for the climate impact of that resource that's taken from other sectors, and you add it into the system, you find that in some scenarios, transitioning to SAFs can make the problem worse. In the best cases, it's sort of about a 50 to 70% reduction in emissions by 2050. And we need to make sure we're on the right trajectories. And to do that, we have to think not just in an aviation sector perspective, we have to think in a cross-sector perspective.
Now, when you say cross-sector, what do you mean? How does aviation coordinate with other sectors? What does this collaboration look like?
So there are sort of three ways that you can make your fuels truly sustainable and offset this cross-sector effect. So I can talk about, well, there's no one thing which is a truly sustainable fuel. So that's the challenge. But I'll give you three basic rules which show that is good behavior. So the first one would be that you choose a fuel production route which is carbon efficient. So if you've got, say, power and biomass to liquid, in a power and biomass to liquid plant, you're taking all the carbons in the fuel and you're upgrading them with green hydrogen and electricity to make fuel. And therefore, you require much less carbon than if you had biomass to liquid, in which about 2/3 of the carbon has to be stored underground or released in the process. So those carbon efficient power and biomass to liquid would be an example. They reduce the requirements for biomass and therefore make it more possible. The second one would be using CCS. So effectively, you're using too much carbon, you're using too much biomass, but you're offsetting it by storing your carbon from the production underground, and that also works. And the final one is to coordinate with other sectors. So, for instance, if you have a power station that's running on coal and you co-locate your production of fuel with it so that the biomass goes into the coal plant, but then the carbon is stored or is taken out of the exhaust and used in the fuel, overall, across the sectors, across those different sectors, you can get a reduction in emissions. But you need
Right.
that level. You need to be
Through the
thinking at
levels.
that level about
Very,
the plans.
very, very interesting.
Yeah.
What about the cost of SAF, Prof. Miller? Because SAF is costing more. Will this increase the price of flying and travel?
Yes, it does. So the ticket cost for SAFs are most of the solutions are about 30% higher, but they do depend on the production route. So we think in the report, we analyze this in overall ticket price, and we think that a biomass to liquid solution in 2050 would cost about 30% more. We think a power and biomass to liquid would cost about 60% more. And we think that power to liquid would cost about 80-90% more. Now, the uncertainties on these are large, and you can see the uncertainties in the report. But the cost, the capex involved with building a lot of these plants is very high.
I know that's a tough one, isn't it? Getting over that FID for the first plant line. But I want to talk a little about your moonshots goal as well. That's the final thing, which is the big moonshots. Tell us about this category.
Well, before I come to moonshots, just let me say one more thing about the SAFs, because I think it's important. If you look at, there's a whole range of reports out that estimate the amount of global biomass which will be available across all sectors. And they range from saying there's about 50 exajoules to there being about 160 exajoules. So it's an incredibly large range it sits in. And so what we have to do is not just aviation, but aviation and all the other sectors together have to get under this limbo bar. And this limbo bar is likely to change as we get more information about the consequences of collecting biomass, the effect on biodiversity and food and land use. And so if you can see in the report, there's two ends to this. There's a sort of extreme scenario. And the extreme scenario would be we went for the most carbon efficient SAFs. So aviation really pushed the limit, like power and biomass to liquid. And at the same time, other sectors only used carbon where they really needed to. Things like plastics, things like wood or pulp, things that are impossible to move to other sectors. And when you put this together, it shows that really you're needing about 70 exajoules. So you're already in this range. If you allowed aviation to go down a biomass to liquid route, so a less carbon efficient route, and you let other sectors not be as efficient, or to more sectors to use carbon, for instance, you left 15% of electricity production on the grid and you allowed large vehicles to use biofuels, then you end up being way over the 160 exajoules. So we have to be aware of this limit. And we have to, this is the importance of thinking in a cross-sector way.
Very, very interesting. And I don't think this is an easy task, but you do have a rather ambitious category in your report called moonshots. How does that work?
So the moonshots are interesting. So to have we haven't reached that Tesla moment, as I talked earlier about. So we do not know yet whether we're going to have to solve this problem with SAFs alone, or whether a technology is going to come in like Tesla did with battery electric cars. And so our aim with these should be to maximize the chance as early as possible with understanding whether they can play a part in the solution. And there's a number of them, but the cost of actually trying these out to a level where we understand whether they can play a part is important. What you have to make sure is that any one of these moonshots has the capability of really getting into medium haul or perhaps long haul, because they've got to play a big part in the solution. And the ones that look most attractive to us are cryogenic hydrogen, cryogenic methane, as a fuel looks very positive. Synthetic biology. So at the moment, the way fuels are made in the Fischer-Tropsch process is the molecules are all bashed up and statistically put back together. And that is inherently a high pressure, temperature, high energy environment. If you could program the genome, change the genome of an algae to produce something that was close enough to a kerosene, that could be done at much lower energy than the Fischer-Tropsch process. So that would be a true moonshot. And then finally, hybrid electric. And hybrid electric, especially fuel cell electric, has the ability, we think, as you get into the 2040s, to eat a lot of the European market or the American internal market from the bottom, the medium haul stuff. So those four areas we think are really exciting, but there are other ones.
Very, very interesting. You mentioned hydrogen and methane specifically. Do you foresee one or the other will play an outsized role in the future of transformation aviation?
So I don't think I'm not a hard backer of hydrogen or a hard backer of methane. I don't know what the solution is. I think anybody who tells you they know what the solution is just wrong. I mean, it's like predicting whether Tesla would have occurred or whether it would have worked. The important thing to do is to really de-risk those technologies as soon as possible. And by the way, any country who does this is going to get a major advantage because they're going to win a new industry for a relatively small upfront cost. Now, I think if we talk about hydrogen, hydrogen has a big advantage, and that big advantage is it's light, and it's about a third the weight of kerosene. And even when the tanks are included, the cryogenic tanks that store it at minus 253 degrees C are included, it's half the weight of jet fuel. And you obviously have to move. The cryogenic hydrogen can't be stored in the wings. It's about 4 times the volume of kerosene. So it's moved into the aircraft. The aircrafts get much bigger. The drag and weight of the aircraft goes up. But as you get to long haul flight, the percentage weight of the aircraft that's fuel, it becomes large. 45% of an aircraft long haul flight, 40 to 45% is fuel on takeoff. And that halves. And that has a real advantage. And so we think, and this is high, has a high uncertainty. We think probably around a 737 type aircraft, they're about the same. As you get to long haul aircraft, there's a good chance these aircraft will have around a 10% lower energy per passenger kilometer of flight.
This is a great angle, yeah.
And by the way, there's one other thing that's really important. By the way, people don't seem to. There's a lot of myths go around about hydrogen only being good at short range. That's just wrong. The physics shows that's not right. But there's another real advantage. So when you liquefy hydrogen, it's like a battery. You're storing work in the liquefaction process. And that can be extracted in flight. And that gives you about another 10% if you have a new type of engine that exploits it, reduction in energy per passenger kilometer. And we show in the report, you could be talking about sort of quite big gains at long.
Very, very interesting. This is something that I was not familiar with. So thank you for enlightening me. Now, given the steps you're seeing from airlines, from countries, are you an optimist or a pessimist when it comes to aviation potentially achieving its net zero goals?
Can I just, like to say on the hydrogen that the real challenge on hydrogen is the distribution. It's changing the airports. That is the real
the transportation
challenge.
And distribution. You're right.
And yeah, transportation distribution is a real challenge. And actually, we've done quite a lot of work on conversion of airports. And one of the benefits of long-haul hydrogen is that about 50 of the world's largest airports use about 50% of world jet fuel. So actually, the conversion of those airports is is really is in a way an
Did you say
opportunity.
15% of the world's large? 50%.
50. And the other thing the other challenge is changing the fleet over. Obviously, you've got to do all the research and development, and we've got to produce those aircraft, and then they've got to penetrate the fleet. So they're not going to have an impact anywhere nearly as quickly as SAFs. And we in the report, we have done quite a lot of analysis on the time it would take to do that. But we believe that by about 2050, you could have 10 to 30% penetration of hydrogen aircraft. And by 2060, you could have about 30 to 70%. But unless you do these 5 years of research development, you really go for it and you prove it's possible now, that will not open up that future
very,
scenario.
very, very fascinating. Now, final question, Prof. Miller. Given the ambitious nature of these goals, how confident are you that the aviation industry can achieve net zero emissions by 2050, and what are some of the biggest obstacles?
So I think when we run the scenario forward with people's current announcements, it is highly uncertain, the future. So the beauty of the Aviation Impact Accelerator model is we can track the uncertainty through the system. And you get, and we show in the report, we could end up doing SAFs badly, scaling it up, but not in a sustainable way. And it could make the problem worse. Equally, it could make the problem better. So the uncertainty is very high. However, what makes me positive is the fact that when you, through a combination of these 2030 goals, if you really pushed the majority of them, and over the next 5 years we had focus, you find whole new futures open up. And we can make net zero by 2050. There is not just one solution through the maze. There's quite a few solutions through the maze. And it's really interesting on the dashboards, that we had from the workshops we talked about earlier, that you could, for instance, decide, you could reach a point in 2030 where all the moonshots fail, and you could go really hard on truly sustainable SAFs and systems efficiency. You could push the bold measures, you could incentivize those scrappage schemes, the flying slower, and a combination of those, as long as you track them through hard, get us to net zero. Or if a moonshot comes through, the methane or the synthetic biology or the hydrogen, again, there are other scenarios through the maze. And just one more point on this. It's really important that policymakers in making investments understand how those investments can change those future scenarios. But it's also really important that when we get past 2030, as we start driving these changes through, we need to really work in a more sophisticated way through these dashboards, and we need to monitor things, how things are going, and we need to change the way we develop policy as we go.
Fantastic. Well, thank you for giving the tools to the industry, to policymakers to make these decisions. I found the report very encouraging. I'm truly delighted to see the collaboration across universities from Cambridge to MIT to come up with this work as well. The final part of this interview, Prof. Miller, is what we call the rapid fire round, in which we get to know you a bit more personally. And I know we have not prepared for this, so I will ask with something very, very simple. What's your favorite?
Yeah. Well, before we just start that, can I just say, I think I need to thank our industrial partners who funded this work and governmental partners, because the vision they've shown, this is not, they don't know what we're going to say. They've worked with us and they've worked incredibly, and I think it's really important that the way these international companies have come together to fund work, which may not agree with their policies, but allow them to get amazing insight into the future, I think is incredibly encouraging. So I'd just like to give thanks to them.
Yes,
so,
thank you for that acknowledgement.
Round.
Rapid fire round is where we get to know you a bit more personally. And I'll start with something very simple, like what's your favorite book?
Well, actually, the book I've read most recently, and is currently my favorite book, is The Jetman by Frank. It's the first biography of Frank Whittle. And it's astonishing there's not been a biography of Frank Whittle before. and it gives you insight into the difficulty he had working across government and industry at speed.
And this is just for context for everyone. This is who the Whittle Lab is named after.
Yeah, the Whittle Lab is named after Frank Whittle. Frank Whittle ran the first jet engine in 1937, and he started Power Jets, the company that ran the first engine, while he was still doing his undergraduate degree at Cambridge.
Amazing. I will definitely look out for Jetman and check it out. What's your favorite airline?
Favorite? Oh, that is terrible. I have to say it is Emirates, because Emirates have been an amazing sponsor of the AIA, and they really have given us access to things, and I think they're really pushing on the sustainability.
Fantastic. Glad to hear. I know the great work Will Lofberg and Shannon and their teams are doing, so glad to hear that. What's your favorite city?
Favorite city? I have to say London. I mean, London has absolutely everything. I mean, from arts to food.
Indeed. Can't go wrong with London. Favorite movie?
Favorite movie? Oh, that's an interesting one. I tell you a movie I really enjoyed when I first saw it, which was The Seven Samurai.
Okay.
Kurosawa, which I think was fantastic. And cinematography in
Wow.
that is astonishing.
I have two things to check out: a book and a movie now this weekend. Thanks to you. What is something that you do in your free time?
I really like to travel. I spent a lot of time traveling when I was younger in Central Asia, the Middle East, and so I find that life's incredibly busy. So getting off the beaten track and just staying in local places, I really enjoy.
What is something you'd like to learn?
I think this experience of setting up the Aviation Accelerator has been the fastest learning process in my life. I think we are incredibly siloed in the aviation sector. And so I've enjoyed learning about biomass, about the way fuel's made, about the way aircraft fly, about the nature of policy and how you develop policy. The rates at which you learn in this in decarbonising aviation is wonderful, and so I feel I'm at the start of the journey, but I'm really enjoying it.
That's great. Final question: what is the best advice you've received?
The best advice I've received, I think, the best advice I've received is always challenge yourself to go further and take on the bigger challenge. I think so many academics and people in industry end up in silos. And I think we all should challenge ourselves to sort of think bigger about the problems we're solving. And climate change really requires us to do that.
Fantastic. On that think bigger note, Prof. Miller, thank you very much for your time. I'm glad we were able to finally do this, and I do wish you all the best.
All right. Thank you. Lovely to talk to you.
Thank you for listening to this episode of Sustainability in the Air. Aviation is one of the hardest to decarbonize industries, yet there are multiple paths to get to net zero. Awareness is key to a green future. So please give us your support to help our Sustainable Aviation Insights reach a wider audience. You can do this by sharing this episode on your network, on LinkedIn, Twitter, or even WhatsApp. Or perhaps you might consider leaving a review on Apple Podcasts, Spotify, or wherever you listen to this episode. You can start a conversation with us by writing to us at podcast@simpliflying, that's simply with an i.com. And for more content on sustainable aviation, please visit our website green.simplifying.com and join the movement. Sustainability in the Air is an original podcast by Simplifying. The show is produced by Juraj Toth in Slovakia. Dirk Singer is our Director of Sustainability, who leads research for each interviewee out of Greenwich, UK. Shubhadeep Pal is our supervising editor based out of Mumbai and Singapore. The articles are written by Ayushi Badola in Dehradun in India and Mira Hull in Montreal, Quebec. Creative design is led by Ligia Esteve in Montreal. Baiba Drimain is the project director for the show based out of Valencia, Spain. Special thanks to Wendy Sim in Singapore. And I'm Shashank Nigam, the CEO of Simplifying and your host. Please feel free to connect with me on LinkedIn.